What's up, y'all? This is Tom, and this is Like a Math Class. In this video, we're going to continue our conversation of calculus, and we're going to look at the product rule. Now, typically, I like to talk about where do these formulas come from. In this video, I'm going to do a slight departure from that because, quite honestly, finding like the rule that creates the product rule, it's a very big process using the first principle. So we're going to actually just jump in and say, here's how you use it, here's what it looks like, and then apply it. So let's get to it. The product rule says if your function is the product multiplying of two other functions, then your derivative is all this. So what does this mean? What is the product of two functions? Maybe we say that u of x is equal to x squared plus 2. And maybe v of x is 3x squared plus 4x. Or something like that. So what's happening is we're taking u of x and we're multiplying it by v of x. Now, of course, we could always expand these two things out and do the sum and difference rule with our derivatives, but we're going to see, is there a kind of a shortcut way that we can do this to find the derivative of this piece times this piece. And that derivative looks like, it says take the derivative of u, so take the derivative of your first function times the original of your second function plus the original of your first function times the derivative of your second function. Normally I would like to go through that whole process, but that's going to be a whole video in and of itself. So we're just going to kind of cut right to the chase, and we're just going to see how do we apply this idea. So let's take a look at an actual example here. Here we've got find the derivative of f of x if f of x is x cubed plus 4 and x squared minus 7. One way that you can organize your information is to actually write out all the different pieces. So some people I've seen write out, they say, okay, I'm going to call u of x, I'm going to call that x cubed plus 4. And I'm going to call v of x, I'm going to call that x squared minus 7. And then we could even go so far as to say, I'm going to find u prime of x, or the derivative of u of x, and that's going to be 3x squared. And then we could also say, I'm going to find the derivative of v of x, and that's going to be 2x. So now that we have all four of these pieces, we've got the original u of x, which would be the original u of x. We have the derivative of u of x. We have the original of v of x. And we have the derivative of v of x. And the reason I color code them like that is just like up above. If our function is u of x times v of x, so u of x times v of x. So let's map this out. Then the derivative of the function is going to be the derivative of u of x. All right, so that's going to be our green function, times v of x. All right, well, that's our original blue one here, plus the original u of x. All right, there's my yellow. And then finally, times the derivative of v of x, which is our pink. So quite simply, all you have to do is drop in these four pieces into this equation and then do some simplifying. So let's see what that looks like. We're going to have f prime of x is equal to 3x squared. That's this. I'll color code it here in a second. 3x squared times x squared minus 7 plus u of x, which is x cubed plus 4, and that's going to be times v prime of x, which is 2x. So again, matching up our colors, our derivative of our first function is this. The derivative of the first function is this. The original of the second function is this. Then we have the original of our first function, u of x, there. and then we have our derivative of our second function. And now I'm just going to do a little bit of simplifying and see if there's any combining of like terms that I can do. So I'll take 3x squared and multiply that, distribute that across this parentheses. So I have 3x to the fourth minus 21x squared plus, and now I'm going to distribute the 2x across these two pieces. So I'm going to have plus 2x to the fourth plus 8x. And now I look for my like terms. Here's two like terms. So I'm going to just take it that one step further. So 5x to the fourth minus 21x squared plus 8x. Now the question is often, do I leave it there? Do I simplify? Do I try and factor it? You know, those are kind of personal preference questions, I say, at this point, because if you simplify, if you factor out an x, yes, that might make it a little bit more simple to look at. It might make it a little bit easier to look at. You could try and factor it, but ultimately what you're trying to do is find the slope at a specific point. So if we were to extend this question and say, hey, what is the slope at x equals 1? By going through and doing all that extra work of factoring out the x and trying to factor this into two sets of parentheses or something like that, it's not going to really help much because really what we want to do is we want to take this 1 and be able to drop it into these x's and just do a quick calculation to find that slope. So I don't know if I would really go much further than this. Here, for sure, I would combine these things. I would combine the 3x to the fourth and the 2x to the fourth because those are indeed going to simplify out a little bit easier and make our calculation just a touch easier. You know, it's like I said, it's kind of personal preference. At one point, we're going to start doing some analysis of graphs, and maybe then we will do a little bit more breaking down and finding some zeros or other ways to write this. Let's look at one more example just to kind of see again how this works and maybe combine it in with our chain rule. So our next example we have is find the derivative of y with respect to x when y is equal to all of this. Square root of x times x cubed plus 1 all squared. So again, I could, if I'm not real comfortable with the product rule, I could open up these parentheses, distribute across, multiply the square root of x across all of that, but that feels like a lot of work for me. So I'm going to try and come up with a shorter way to do this, so that way we can try and save some time as we're working through these problems. So I'm going to rewrite this to begin with as x to the 1/2 power, and then just keep the rest of my problem because I can't really do a whole lot more than that. And if we were to continue and use this same idea that we did up here, we would want to find the originals and the derivatives. So here we could call our u of x. Let's call our u of x, and let's call that x to the 1/2. And let's call our v of x x cubed plus 1 all squared. Then our derivative of u is equal to 1/2 x to the negative 1/2. And our derivative of v is, okay, again, I'm going to do the chain rule. So 2 comes out, so I'm going to take the derivative of the outside. So I'm going to have 2 times x cubed plus 1 to the first power times the derivative of the inside times 3x squared. And I could probably even simplify this a touch further and say that's going to be 6x squared times x cubed plus 1. Maybe even, because we've got all this, maybe we even distribute this in here. But let's just wait a second just to see how this plays out. And we had our colors. How did we have our colors? We had yellow, blue, green, pink. Yellow, blue, green, and pink. All right, so the derivative of y is equal to the derivative of u, 1/2 x to the negative 1/2 times the original v, x cubed plus 1 squared, plus the original of u, which is x to the 1/2, times the derivative of v, which is 6x squared times, again, x cubed plus 1. Okay, so now we can see, yes, we're definitely going to want to do some distribution in here. Let's just do our color coding. So here is our u of x, here is our v of x, our u prime, and our v prime is here. All right, so let's simplify this. So y prime is equal to, here I don't think I'm going to do a whole lot because this is squared. I don't want to expand all that out. This is going into the denominator, so maybe I start this by saying 1 over 2 square root of x time, not 1 over, let's put the blue in the numerator, and maybe we put our x cubed plus 1 squared in the numerator. So let's start with that and see what happens. Plus, this inside here, we could multiply these things and then this would be multiplied in there, or because these are 3 multiplications, I could also look at it like this. I could also put this parenthesis right here. And so these two things don't have to be multiplied together first. So as I distribute these two pieces, I've got the same base, different exponents, which means I add those up. So I'm going to have 6x and let's see, 1/2 to the 1, so 2 plus 1/2. So that's going to be 4 over 2 plus 1/2, 5 halves. So x to the 5 halves power times x cubed plus 1. You know, I think I'm just gonna distribute this because I don't have a power out here, and I'm just gonna kind of see what happens with this. Y prime is equal to x cubed plus 1 squared over 2 root x plus, well, wait a minute. This thing is common with this, right? This is this piece to the first power, this piece to the second power. I could actually factor out a bit there. I could factor one of those out. So let's do that. Let's take x cubed plus 1 times x cubed plus 1 over 2 root x. And again, if I were to multiply this back, that would make that thing squared, plus 6x to the 5 halves power. So I don't know if there's a whole lot more that we could do at that point, and that is what I would call our final answer for this question. So you don't necessarily have to factor this out, but when we get to the quotient rule, you're going to want to kind of start recognizing how you can factor out chunks like that, like whole parentheses, because in the quotient rule, which we'll do in the next video, you'll definitely be able to simplify and cancel out some of those in the numerator and denominator, and make your fraction or your result a little bit easier. So that's it for this video. I'll see you in the next one.